Okay. It's about the potential of the large language models for normative reasoning. So this was the paper that we submitted to the original Amos Blue Sky. One reviewer absolutely loved it. The other one absolutely hated it. They hated it because they didn't want anything to do with the LLMs, right? So we submitted to COINE, and COINE reviewers loved it. So so this, as you all know, like a blue sky idea is an opportunity to present what you think might be a feasible set of ideas that you could implement in the future. So there's a joint work with Surangika Ranatunga, who presented a paper early on the use of LLMs, and Stephen, who is here. So this was the original thought, which actually took us towards the branch of using large language models for normative reasoning. It would help if I went out of.
Oh, actually, you're probably in the Zoom. You probably need to change to PowerPoint.
Okay, is that? All right. So I'll provide a brief context and motivation for our work, and then there's been a lot of work that has happened in the NLP area on norms and LLMs. So norms and LLMs have not been integrated yet, but although I did see at least one other talk that integrated it in one of the workshops, but this work on LLMs and norms has been widely studied in the NLP area. So we are encouraged by that, and then how we can actually take that research and apply it to multi-agent systems is what I'm going to talk about. And then finally, a set of challenges and limitations. So in multi-agent systems, we're interested in agents collaborating and coordinating with each other to achieve goals. And a range of social mechanisms have been explored, from norms to trust, reputation, values, goals, preferences, values, as we saw this morning, which are related to norms. And even within the norms community, you can see there's a diverse body of work. Different people call their work differently: conventions, norms, laws, commitments, social practices. I think they all have expectations as a common body. So this slide is just to highlight that in the future, there will be embodied agents, robotic agents, that will need some abstraction of social concepts. They need to apply social concepts if they are embodied in a real world where these robots and humans cooperate and collaborate. So, so you can see those scenarios here in the diagrams. But our focus has been on norms and normative multi-agent systems. And one of the main goals in normative multi-agent systems is to create norm-capable agents. And I've defined a set of norm capabilities here. And I haven't added references because I'm going to assume that this is common knowledge. How do agents propose norms studied under norm entrepreneurships? How do agents identify new norms? How do we detect violations? So detecting violations was the focus of the other paper that we saw this morning. And how do we reason about norms in decision making? How do agents apply sanctions? How do we resolve norm conflicts and norm revision? So these are various branches of research in normative multi-agent systems. And there are several limitations of the current work in multi-agent systems in general, because we use symbolic reasoning. Symbolic reasoning is often brittle. So, and also, in many cases, we hard code norms. We don't allow certain things to happen. That's how we handle it. And also, many of the scenarios that we consider are toy scenarios. I have been guilty of that in my own work. We have looked at simple park littering scenario, tipping scenario, and so on. But in real life, the norms can be much more nuanced and complex. And also, our formal mechanisms cannot cope up with the rich social understanding that we have in natural language. So natural language is very expressive. But when we look at our symbolic representations, they're often confined to very small, simple problems. They're not that rich. But we do have this potential to bridge all of these gaps if we can harness the large language models. So there's been a lot said about the promises the promises of large language models. So I brought some codes from the recent work. So the main focus of all these codes is that large language models can capture the rich social understanding of how we operate as humans from these large data sets. So Park et al. Have noted that we can create believable agent systems that can mimic emergent social behaviors. And there is a nice work which is not yet been published, which is in this particular area. If you have time, I'm going to show you a screenshot, which actually looks at how norms can emerge using large language models, where they have connected a simulation environment to a large language model, and they show the norm emergence can happen. And Andreas et al. Have indicated that large language models are models of intentional communication. So what this means is, if we prompt these large language models for BDI-like scenarios, they will respond to you with the BDI-like constructs. Okay, so when you have those constructs, then it is up to you how you could potentially translate these into, for example, symbolic mechanisms, and these symbolic mechanisms can help can then be run using programming language, platforms like JSON and so on. And also, there's a lot of culture-specific data that is available, so we can harness that information. So based on our research, we have found that prior work on LLMs can be classified into these two branches. Of course, this is our own classification. One is the NLP work on LLMs and norms, and the second one is the agent-based architectures, which have been proposed not by the multi-agent system community, but it also comes from the NLP community. Okay, so both these works come from the NLP community. So the first branch is on norms research using LLMs from the NLP community. The first branch, in the first branch, there are three parts. The first part is on the norm discovery. Discovery is all about what norms are applicable to me in a given context. So if I am an agent, what kind of norms apply to me? And these are inferred based on large data sets, which are chat conversations, stories, narratives, and so on. And this is modeled as a text generation problem. So the problem is, given my applicable scenario, can I now generate norms either generate norms that are applicable to me, or can I now even propose new norms? So the way the people have approached it is to query the LLM like ChatGPT to identify what the norms are in a given scenario, describe a scenario, and then ask for what a norm is. Or people have fine-tuned human annotated data. This is mainly to reduce bias, because the large language models are usually biased towards the Western societies. If you want to reduce bias, then we need to train it or fine-tune it using specific corpora. And some of the researchers have worked on removing conflicting norms so that they can provide a coherent set of norms. The second line of work is on norm reasoning, taking reasoning about norm violation. People have translated that to a text classification problem. There are a couple of systems already implemented, Delphi system and Clarify Delphi, which can actually classify whether a norm has been violated or not. So this is already happening in the NLP research. The third one is norm conformance checking. This is just to check whether the agent's actions are compliant with the norms. And here they use a combination of the text classification and text generation problems. They're combining the first two approaches into this third approach, where an action can be recommended. So given a norm, what should be the next action that I should take that will not violate the norm? So there has been prior work on that. But the gap that we've identified is these LLMs have seldom been integrated into agents' decision-making engine. Say, for example, if you're working on a JSON platform, so this integration has not yet happened. Yes, NLP researchers have looked at LLMs and they've queried LLMs for normative understanding, but no one has still integrated to the agent's decision-making engine. And the second branch is on proposing agent architectures. Of course, these agent architectures don't come from one field, it comes from another. So they have identified 4 modules that need to be in an agent architecture so that we can reason about norms using LLMs. The first one is the profile. Profile is a set of attributes. It could include personalities and so on. So that's a profile module, a memory module to store all the historical observations that have happened, and a planning module to plan the next action you must take. And the final one is taking the action. This is the action that the agent wants to do next. So this is a very generic architecture. It's only recently proposed by Wang et al. It has not been implemented as far as I know. So the opportunity here, or the gap here is, yes, it's a generic architecture, but now to make it work, can we actually integrate and also extend these architectures into our own agent-based frameworks? So there are definitely opportunities to do this. So how do you go about developing an LLM agent? So this is our proposal. So we're just going to look at the three phases of the norm lifecycle. We're not going to go over all the phases. The first one is a norm discovery. So we could query an existing LLM for the normative knowledge. So we can connect from an agent engine. We can connect to the existing LLM to identify what the norms are. But it is likely that domain-specific and culture-specific norms may be missing. So one of the contributions of the NLP community is they have created really large databases of norms. So Stephen and I, we looked at it, and we found lots and lots of generic norms and useless norms. So they've just compiled an agent is allowed to do this. They're able to walk out of the room and so on, which we would typically not consider as norms in the norms community. But these are regular patterns. So there are large data sets of norms that are currently available, more than 10 data sets, which if we want, we can actually pull up the norms from those data sets as well. So in the cases where there are no specific norms for the domain, then we may have to fine tune based on annotated data. But the issue is that when you fine tune it, then you are left with a static set of norms. You still have to, how do you dynamically change norms? Because fine tuning at one point in time assumes that the norms are going to be static. But what if the norms are changing? Then you have to fine tune again, right? And when do you stop? And fine tuning is expensive. So that's probably one of the challenges that we need to look at. In norm discovery, we are also interested in the problem of emerging norms. When a norm is emerging, what do we do? Of course, this is where the planning module that Wang et al. Have proposed can be used, or it could be extended. Of course, we need to still build it. We can use theory of mind approaches for extracting what the norms are. And often for norm identification, sanction is a starting point. So if somebody is sanctioned, then we know that something that they did, potentially a norm violation is a reason for a sanction, and we can infer norm based on that. And one of the issues again here is we need to avoid fine tuning every time a new norm is discovered. So what can we do? We could use the memory module. The memory module can have vector databases, or we could use the RAG approach to extract relevant norms. So we don't have to fine tune every time. And the second way we could use, we could connect agents to LLMs is for norm reasoning. And we could use appropriate prompts. And in some of the work that we have done, as you saw in the paper in the last session, it is about prompt tuning, coming up with some prompts and identifying whether the LLM knows about norms. So we could explicitly ask for a norm without just by asking, okay, this is my situation, tell me what the norms are. So that's one way to do it. Or we could say, given my scenario, given a set of norms, am I violating a norm? So that could be the second approach. Or we could incrementally or iteratively ask, using a chain of thought approach, to iteratively inquire about norm understanding. What is the norm? Why is the norm being violated, and so on. So this is the approach that we are currently taking. We are looking at using the chain of thought approach, and Sean's work is based on, Sean who's sitting here, is looking at the chain of thought approach to iteratively query norm reasoning using ChatGPT and the models alike. So the third application or third area in which we could apply is to identify norm conformance. And in norm conformance, we want agents to conform to an action that is aligned to a norm. So these are norm adhering actions. And here again, we can extend the action module of the LLM architecture to generate actions. But these are all well and good in theory. What we need to build is to build or extend existing architectures so that we can have all of this possible, so that we can have a running agent system that can incorporate all of this. So here is a very here's a sample scenario that we thought of. It'd be nice if we can have a robot that can accompany our children at home. And this scenario involves a child asking the robot, Rosie, I want that big sister to cut the paper, okay? Right, now what would you do if, let's replace the robot with a human? What would be your response? The child is 3 years old and it wants a large scissor. What would be your response? I'm just throwing this out just as a, sorry, yes, very good. Yes, that's what I didn't want. So what are some of the norms? It's a safety norm, right? So there is a safety norm, or if this child is a really genius, they've been trained to use the large scissor, but still you probably may need parental consent norm, right? So there will be several norms that may be at play. So there might be norms that the agent is aware of. For example, this could be the child safety norm, parental consent norm, some diet restriction norm. It may know generic norms, but it may not know specific norms to actually respond to that child. So that's where we are in the future, we are planning to experiment with how well the language models can do for these specific norms. It may know generic norms such as safety norm and parental consent norm, but can it actually apply to a very specific context? So we can just query the LLMs and find out, or we can fine tune a model and then get the results and so on. So this is still in the preliminary stage. But what we envisage is using a chain of thought approach. It would go through the life cycle model of the norm, or look at those norm capabilities that I listed early on in the first slide or second slide. It could go through various stages. For example, the first question it might ask is there a norm violation in this situation? So the LLM model may have to iteratively detect or find answers for these questions. So first thing might be about norm violation, whether a norm has been violated. The second step could be asking for an explanation for a violation. So in this case, in this scenario, 2 norms have been violated. One is the child safety norm, the other one is the parental consent norm. So upon identifying norm violation, it may want to, the LLM can then be used to ask a further question, which is to see what is the explanation for the norm violation. The explanation could be that the motor skills of the child has not been developed yet, so it might be unsafe for the child to use a large scissor, right? And then it could also now ask a further question saying, can I now select a norm adhering action? How can I, that is clearly a violation. How can I prevent the violation now? So again, the knowledge of the LLM could be used to harness that. And exactly what Nadini said, you can give the safety scissor, right? It's safe for the child. But of course, even then you may have to ask parental consent. So there might be a layers of norms that will come into play. And with the large language models, we have the potential to extract most of the well-known knowledge about norms. And finally, it can even generate a normative response so that it doesn't hurt the feelings of the child, right? Somehow it nicely words it, saying, if it's not going to give the scissor, it might say something, or it might say, oh, no, I've asked your mom, let's wait for 5 minutes. I'm possibly going to get you the kid's scissors, okay? And the example that I provided only uses some phases of the norm lifecycle models. There has been a lot of work on norm lifecycle models, and I think there is a lot of opportunity to study how LLMs respond to the various capabilities of a norm. For example, Hollander and Wu came up with all these different phases of the norm lifecycle. So there's a lot of opportunity for us to study that. How can LLMs help us with norm creation, norm transmission, sanction detection, and so on. So what are some of the challenges and limitations? So one challenge, and I think it is also an opportunity, is to integrate our agent frameworks with the LLMs. I think this is a gap, but work has already begun in this particular area. I was in the EMAS workshop yesterday, and Felipe's talk was to actually along these lines, at least one aspect of it. So if we have a JSON, say, program, how do we turn, if we want to use LLMs for reasoning, we need to connect it to the LLMs. So the LLMs only speak natural language, but our programs might be in a logical form. So we need to convert our logic to text, right? And then when the response comes back, so again, from text to logic, okay? So that has to happen at some point. So we may have to retrofit our agent architectures so that they can seamlessly connect with the LLM models. Another interesting idea would be to write our agent programs in natural language. Wouldn't it be nice? We can get rid of all the problems of interoperability between different agent platforms. It'll be good to write all the programs in natural language. So the gap here is our agent frameworks somehow need to integrate with LLMs, and we need a LLM integrator. And there have been several limitations of LLMs. And there are some inherent limitations. Of course, they suffer from hallucinations. They are sometimes inaccurate. As you saw in Surangika's talk, it can't do certain inferences. Even in a small household kind of environment, it can't reason like humans. And that leads to inaccuracies. And there are also resource constraints. Cost is an important one. So in one of the research works where they've simulated the entire norm emergence pipeline, it cost them $2,000 to do a simple experiment, because every time you connect with it, you always want to connect with the best model, ChatGPT-4 at the moment. They ran the simulation for 2 days, and it already cost them $2,000 to show norm emergence. So, of course, we don't always need to connect to ChatGPT. It could be other tools. Like we have found Mixtral to be doing really well. And there is also there's a lot of effort in prompt tuning. In the work that we did, it was often a manual, it was a laborious task to tune the prompt to get good results. And also there are some data constraints. I think this is what I think Muninder raised early on as a question. For some low resource languages like Sinhalese, there is not enough data. So the language model cannot do a really good job of identifying norms in those specific languages. So still predominantly it's an English-based data sets. So we can infer norms for generic contexts and specific contexts. It's again a challenge. You probably need to fine tune the data to get good results. So, and there's also a host of ethical and other considerations. Bias, trust, transparency, reproducibility, privacy. So all of these are big concerns. As I mentioned at the start of my talk, I think our paper was turned down because of all of this, which is an inherent limitation to an LLM. But our argument is, if we do not move forward as a community to engage with that conversation, we won't even know whether there is a potential to use or harness LLMs. And our approach is, let's actually try it. Let's try it in the context of norms. We do believe LLMs can enhance our norm competence of an agent. And these architectures are being proposed by communities other than multi-agent systems. We are a bit slow. It has been proposed independently, right? They call it as agent architectures, but they're good ideas. but we can actually embrace those ideas and implement those modules in our own agent frameworks. And one nice output of this would be there'll be a lot of interesting applications. So what we foresee is that we'll be going beyond the tipping norm and the park littering norm. I would like to see this being extended to a whole host of other norms. And this is a very good opportunity to work with the NLP researchers, because they've already done a lot of work on norms using LLMs. So I promise that I will show you one other slide. So these are publicly available data sets for norms. So if you're a norms researcher, these data sets will be quite useful. These are all in our paper. And this is the framework that has been developed by Ren et al. It has not been published. That's why I didn't include it in the main slides, where they have a generative agent architecture. They have an implementation which goes through entire life cycle of norms, from creation, representation, spreading, evaluation, and compliance. And they show using a small scenario, they simulated how a non-smoking norm can emerge, and how when an agent identifies a non-smoking norm, then they can persuade others to actually adhere to that particular norm. So it's a very interesting scenario. But as I said, this cost them $2,000 just for one small experiment. So, but I believe in the future there is going to be a lot more. But this work also hasn't integrated. It's mainly a simulation. It's not integrated into an agent framework like JSON or JDEX and so on. So there are definitely opportunities. With that, I will conclude my talk. Yeah, thank you all for listening.